0.6. Today we're going to learn about statistics in psychology. So we need to analyze data through measures of central tendency, that's mean, median, and mode. So you should be able to do that by now, and assess significance through effect sizes and meta-analyses. All right, so we're just going to learn all the math terms that we need to know for AP Psych in this 0.6. So sit back and enjoy. Statistical analysis techniques in psychology. Statistics. A large amount of data can be collected in research studies. Psychologists need to make sense of this data, and they make sense of it with statistics. As we saw in your naturalistic observations already, or any survey data that we've looked at as a class already, we look at statistics in order to make sense of anything. We want to find trends in the data. We want to see what the data is telling us. So a lot of psychology is data analysis, and it's kind of fun to analyze the statistics of any psychological research project, which you did in naturalistic observation, and which we will do again and again on future research projects. So there's two types of statistics, right? The ones that we've dealt with so far are descriptive statistics, right? Descriptive statistics refer to numerical measures used to summarize and describe the characteristics of a data set. So when you did your naturalistic observation projects, you described the data that you saw. You said 66% of students, speak Korean in class or whatever it was. You're just describing a behavior, descriptive statistics. Now there's something else that we're going to learn called inferential statistics. And this is what really makes statistics interesting and what makes a relationship between two variables provable. All right, inferential statistics involves using data from a sample to make inferences or predictions about a larger population. So can we generalize this data set to a larger population? That's what inferential statistics are all about, making predictions or generalizations about a larger population. And there's a specific way that psychologists accept and how we use and calculate inferential statistics, which we will learn soon. So let's start with the easy stuff of descriptive statistics. Descriptive statistics, the main method of describing stats is measures of central tendency, which at this point in your school lives, you'll already be experts at, but I'll review them here, mean, median, and mode. The mean is what we consider the average. The average, when someone says what was the average, they're talking about the mean, which is you take all 5 data points, add them up, and divide by 5 to find the mean. So in this case, 10 plus 15 plus 20 plus 25 plus 30 divided by 5 is 20, hopefully. That's the mean. The average, and then you got the median. The median is the number in the middle. So you got a data set that looks something like this, and you just want to find the number that's in the middle. Okay, 10, then 15, and then 20, and then 25, and then 30. Oh, it looks like 20 is in the middle. 20 is my median. So this is another way to calculate the average, right? Because it's not always smart to calculate the mean because it could be misleading. Like if I say the mean, if you look at the average income or salary that a person makes, and you only look at the mean, then the average salary is going to be way higher than what reality indicates, because some people are billionaires, right? And they're going to pull the mean way up. And the mean, looking at income, the mean is unrealistic, right? You want to look at the median. What's the middle person making? This would make your data a lot clearer and more realistic. So sometimes we use the median, and then sometimes we use the mode. The mode is the number that occurs the most, right? What's the most popular amount of times that something occurs? So here, 10, 15, 20, 25, and 30. Here, there is no mode because none of them appear twice. A mode would be if one number appears 2 or more times, or whichever number appears the most is the mode. The range represents the difference between the highest and lowest values in a data set. So you would simply take 30 and subtract 10. 30 minus 10. My range is 20. That's your range. How big is the range of your data set? All right, now we're moving on to slightly more complicated things, and these are guaranteed to be on future assessments and guaranteed to be on your AP exam. Normal curve or bell curve, right? This is a bell curve. All right, we're going to do a little activity in class related to this bell curve, but for now, just introducing it. One more term before I introduce the bell curve is regression to the mean. This is when extreme scores tend to get closer to the average when measured again. This happens because extreme scores are often due to temporary factors, not lasting characteristics, right? So we took one test in psychology and some people got Fs and some people got 104%, right? But over time, if those people keep testing, hopefully they regress to the mean. They become more average, right? There are always outliers in any data set, but the more data that you collect and the more times you do something, the closer it will be to average. It regresses to the mean. It goes back to normal. If someone scores usually unusually high or low on a test or performance, the next time they're measured, their score is likely to be closer to the average. Right? You can't continue to be an outlier. It's unlikely to continue to be an outlier. Most things regress to the mean. Now we've got positive skew and negative skew. Positive skew on a bell curve. I guess I haven't fully talked about the bell curve yet. It's just a normal curve, a normal distribution of data where the mean, median, and mode are all the same. Let me go back here. The mean, median, and mode are all the same in a normal distribution. There's an equal amount of people, of scores on the left and on the right. And this is the average, the mean, median, and mode. This is a normal curve. And let's go back to non-normal curves. So sometimes, most of the time, a curve is not normal. It either has a positive or negative skew. So what does this mean? A positive skew means the majority of the data clusters on the left side of a curve, with the tail extending towards the right, suggesting the presence of outliers or unusually high values. So if you look at a graph of number of pets people have, right? Most people have 1 or 2 or 0 pets, right? Most people have 0, 1, or 2 pets, right? But some people have 10 pets, and these people are pulling the mean, or they're pulling the distribution to the right. It's a positive skew. There are high outliers, positive skew. They're pulling the data to the right. Imagine it as a rope that the high outliers are pulling in a positive direction to the right. Distribution of points scored in the game. If you think about the NBA or, yeah, these are like basketball scores. Most people are not scoring 20 points, right? Some are. Most people score 4 points, 5 points. Most players on a basketball team are scoring 4 or 5 points, maybe 6 points, right? And then you've got a few players on the basketball team who are scoring 20, 25 or more, and they are skewing the data into the positive direction, positive skew. And then we've got negative skew, where the bulk of the data is high on the right side, with the tail extending towards the left, suggesting the presence of outliers or exceptionally low values. Right, so here's an example of distribution of age of death. Most people die when they're 58, something like that. All right, 60. I don't know if this is a worldwide statistic or what, but yeah, let's say most people die when they're 60, but some people die when they're 15. All right, and these people are pulling the data to the left. They're negatively skewing the data. It's a negative skew, right? There's not that many people that live to 100. There's not that many people that live to 75 in this graph, but we have some young people that die way too early, and they're pulling the data to the left. They're skewing the data in a negative direction. Same with our exams in our class, right? The tests in our class, like most people score in the mid 80s, which is great. That's wonderful. Some people score 100, and some people score a 0 or a 20%, and they're pulling the data. They're pulling the average to the left in the negative direction. It's a negative skew. They have low outliers, negative skew, positive and negative skew. Now we've got standard deviation. Standard deviation is, we don't have to calculate standard deviation in this class, but we do need to know what it is. It's a way to measure how spread out or close together numbers are in a group. So if we take a test and the standard deviation is 10%, that means the average distance between students is 10%, which is quite high, right? The average distance in percentage between you and another student is 10%. It's quite high. When I give a test, I'd like my standard deviation to be a lot lower, right? I want people to be on the same page, like everyone is closer together. High outliers will make the standard deviation higher. All right, so what we need to know here, at least in AP psychology, I won't make you learn this in Intro to Psychology, is how many standard deviations in a normal curve are there, and you need to memorize these percentages. So let's figure this out. So in a normal bell curve, you'll only see normal bell curves and positive and negative skew on any test. In a normal bell curve, 99.72% of, you have to remember just 99%, 99% of the data is within 3 standard deviations of the mean. All right, so here's the mean, this is the middle. This is 1 standard deviation. Let's start from here. 1 standard deviation, 68% of all data is within 1 standard deviation of the mean. 95% of all data is within 2 standard deviations of the mean. And 99% is within 3 standard deviations of the mean. If you're completely lost right now, it's okay. We're going to practice this more in class. But if you're not completely lost, you have a huge advantage on this class. There's going to be a lot of this on the AP exam if you're in AP. All right, so again, we'll practice this in class. Percentile rank is something that I'm sure you're all familiar with. It tells you what percentage of scores in a data set fall at or below a particular score. For example, if your score is the 80th percentile, that means you scored higher than 80% of most of the people who took the test. When I go to the doctor with my daughter Javi, the doctor tells me what her percentile is for her height and her weight, right? So my daughter Javi is in the 50th percentile of height and in the 60th percentile of weight. So she's average height, she's a little heavier than average, and she's in the 80th percentile of head size, meaning of other people her age, she has a huge head. She's in the 80th percentile. Her head is bigger than 8 out of 10 to 8 out of 10 people her age, right? So it's important to know percentile. The ACT and the SAT also use percentile to judge you versus other students, right? They use it to grade you. That's called percentile rank. And students at schools have a rank, have a percentile rank versus other students. It's just hidden information that you'll never find out. And then we got bimodal distributions. All you need to know about a bimodal distribution, you won't see it very often, but it's a distribution of data that has 2 modes, right? So it looks like this, right? And there are 2 modes. A type of data distribution where there are 2 distinct peaks or high points on a histogram or frequency distribution graph that indicate that the data has 2 modes or values that occur most frequently. So is this a good, here's a perfect example of this. Let's say you survey a group of people on how many hours of sleep they get each night. I've seen these surveys, and this is true. If there are 2 common responses, 6 hours and 8 hours, you'll see a bimodal distribution. Nobody says they get 7 hours of sleep. They either say they get 6 hours of sleep or 8 hours of sleep. So then we have a bimodal distribution. Looks like that. Now, one of the hardest terms to fully understand, but not a hard term to sort of understand. And luckily, you only need to sort of understand it to succeed in AP psychology or intro psychology. Statistical significance. Okay, so descriptive statistics are very nice because we can describe data, we can look at averages, we can look at pie charts and bar graphs, but that doesn't really do it in the real world when it comes to research or proving a hypothesis, correct? Or proving a link between 2 variables, correct? It doesn't really work like that. In psychology or any social research or any science, you have to prove statistical significance between data sets. So for example, if I give, if let's say our naturalistic observations, and we notice that boys go to the bathrooms more than girls do, or girls eat more salad than boys do, right? So I can describe that through descriptive statistics, but I don't know if being a boy causes going to the bathroom more, or being a girl causes you to eat salad more than boys. In order to prove there is a causal relationship here, or an interesting relationship, I got to prove statistical significance. I can't just describe statistics. I have to show this complicated math equation that you don't need to learn, but we need to understand. Statistical significance tells you whether the effect you found is strong enough that it probably didn't just happen randomly. Okay, so the relationship between variables, the correlation between 2 variables has to be so strong that you are 95% sure your data is accurate, and you're less than 5% sure that your data just occurred by random chance, right? Maybe you did this study and there's a 5% chance that what you saw that day or those days was just due to random chance that had nothing to do with your experiment or observation, right? That's still good enough. In statistical significance, you do a complicated math equation to get your p-value. Okay, it's just called p-value. P stands for probability. And if your p-value is less than 0.05, that's represented as 5% or 0.05, then your data is solid. You can prove something. You can prove your hypothesis correct. You have a statistically significant difference. However, if your p-value is higher than 0.5, let's say 0.06, then there's no statistically significant difference. So even if you notice, boys swear more than girls, and you have a nice descriptive statistic study that shows boys swear more than girls, and you do a p-value test, you might come out with 0.06, meaning there's a 6% chance that the data that you have just occurred by random chance. And if there's more than a 5% chance, then you got to throw that data away. There is no statistically significant difference. Being a boy does not cause you to swear more than being a girl. So statistical significance is a tough term for many students that we're going to need to understand to succeed throughout this year. But this is just the basics. So come see me if you need help understanding this more deeply. We'll try it in class, but it is a tough one. It takes people a while. Statistical significance. All right, and then there's effect sizes. This is a very simple term that you should be able to understand. A large effect size indicates a substantial difference or relationship, suggesting that the independent variable has considerable impact on the dependent variable. So without statistical significance, just ignore the p-value for now, you can see in descriptive statistics, right? 61% of boys went to the bathroom during the class day, and only 30% of girls went to the bathroom during the day, right? You can see the effect size by just describing the difference between these, right? 60 minus 30 or whatever is the effect size. There's a 30% difference. That would be the effect size, right? So statistical significance, extremely important. Practical significance is represented by effect size. What is the effect? Basically, we're already doing this with naturalistic observations and descriptive statistics. A small effect size indicates a minimal difference or relationship, indicating the independent variable has a limited effect on the dependent variable. And a large effect size indicates a large relationship between variables. All right, the final word we're going to learn today is our fifth research method. Remember, we already learned case study, naturalistic observation, correlational study, experiments, and now meta-analysis. You got to know these five. You got to know these five. So a meta-analysis is something you've already done throughout your entire school lives. Every time you've ever written any type of research paper, it has been a meta-analysis. Because a meta-analysis is simply you take a bunch of research studies on the same topic, you combine them, and you make a new conclusion or new argument based on all the research that has already been done on that topic. That's the best possible definition that I've ever given on meta-analysis. So I hope that makes sense. A meta-analysis is just you're taking all the information available on the internet about a specific topic and then combining them into a new paper and drawing conclusions. Look, I studied the effect of Monster. Sorry, again, I just craved Monster. I studied the effect of Monster energy drinks on test scores, and I looked at all the data, and now I'm combining it to form my own conclusion about it. That's a meta-analysis. Hope that makes sense, and if it doesn't, I'm sure it will soon. Thank you for listening to my statistics rant. That's 0.6 for you. Have a wonderful day. See you soon.